All right. So if we took this polynomial function written as factors, and we wanted to find our y-intercept first, we plug in a 0 for x and solve. Well, when x is a 0 here, 0 times 0 plus 2 times 0 plus 3 squared is going to give you a y-intercept at what? 0. So there's our y-intercept, which means this is also going to be an x-intercept. Okay? And so our other x-intercepts are where our factors are equal to 0. So this factor is equal to 0 at 0. This factor is equal to 0 at negative 2. So negative 2, 0 will be another x-intercept. And then the last one would be the value of x that gives you a 0 here is negative 3. Okay, so when you look at those, what you can identify at each of these intercepts is we have an x squared. So what's going to happen at this 0? Is it going to pass through or bounce? Okay, so this one's going to bounce, right? And at negative 2, 0, what's going to happen? It's just going to pass it through. And it's going to pass through in more of a straight line, right? Not in that sort of S shape. Okay, because it's a multiplicity of 1. And then here at negative 3, what's going to happen? We expect that it's going to bounce off of the negative 3. Okay, now each of those actually helps you answer the multiplicity. So the factor of x has a multiplicity of 2. The x plus 2 has a factor, or a multiplicity of 1. And x plus 3 has a multiplicity of 2. Right? And so you can identify that information there. And now at the same time here, what's the total, since it's not on here, but I'm going to talk about the graph here. What is the total degree of this polynomial? So you have 2, another 2, 4, plus 1 more, so 5. And is the leading coefficient positive or negative? So there's nothing multiplied out front, so it's an unwritten positive. Okay, and so just looking at this, here's what you should anticipate regarding its graph. Okay, we have a 0 here, here, and here. Okay, we expect that because it's an odd degree with a positive leading coefficient, is our graph going to go up or down to the left? Down to the left and up to the right, right? So we know these this is what we expect are the behavior of this graph here. Okay, and so when we look at what we have, there's going to be a bounce at the 0. So it's going to curve up here. There's going to be a bounce at the negative 3, so it's going to curve down here. So you're going to have the parabola shapes there. And then here, when you go through the negative 2, it's going to pass, and it's going to pass through almost straight. So it's going to look something kind of like this. Again, I don't really know what's happening in between these. We haven't talked about that yet, but we know our general shape of this graph is going to be something to this effect. And so let's take a look at how our end behavior plays out. As x gets closer and closer to negative infinity, so as we move to the left on our graph, what are we expecting to happen? It goes down. And as x approaches infinity, so as we move to the right, what's going to happen to our graph? It goes up, so it's going to go up to infinity. And then what's the maximum number of turning points going to be? At most 4. Now when we count these, so here's 1, 2, 3, there's 4 turning points, so that fits consistently with what we would expect. And so which of these graph options looks the most like what we were anticipating right here? So this last one would be the solution.